decision to use lethal force is made in a split second and is based on the safety of the officer and also that surrounding community.
The durational concept of the split second is often invoked as a legal defense when the police are investigated for the use of lethal force. But this supposedly indivisible temporality is treated as a black box that tends to isolate the incident from its context. We therefore dived into the split second to examine how the temporality of cognition bears on the decision to shoot. Since we are working from video footage, our smallest unit of recorded time is the frame. There are two types of cameras on the scene. The CCTV cameras record in 25 frames per second, and the body-worn cameras in 30 frames per second. The duration of a frame is therefore 40 and 33 milliseconds, respectively, but perceptual events may exist within or between single frames. Since the footage has no sound, we first needed to establish the exact moment Dylan Halley fired his gun. A good indication was people's instinctive reaction to the sound of the shot. To understand the duration of these reactions, we consulted neuroscientist Professor Tiago Branco, a specialist on the temporality of instinctive decisions and response time at his laboratories in University College London. We showed him the synchronized footage and model and asked for his help in understanding the cognition processes.
Also, how is it that you interpret the likelihood of what's going to happen next? That's kind of the critical thing here, the critical variable.
We noticed two witnesses who flinched at 5:30, 41 seconds, and 4 frames. We worked backwards from this recoil to establish the time of the first shot. It takes approximately 50 milliseconds for a message to travel from the brain to the muscles to enable motor action. Prior to that, it takes about 100 milliseconds for the brain to process the event of a loud sound. And it takes 10 milliseconds for the ear to register a loud sound. This places the first shot at approximately 5:30, 40 seconds, and 24 frames. We also noticed two visible shots through flashes of gunpowder at 5:30, 41 seconds and 9 frames, and 5:30, 43 seconds and 6 frames. We compared and calibrated these results to the data derived from ShotSpotter, a gunshot detection system that establishes the location and time of gunfire using multiple acoustic sensors and is accurate to the millisecond. The data from ShotSpotter confirmed our analysis and allowed us to accurately timestamp our synchronization. The first shot was fired at 5:30, 40 seconds, and 971 milliseconds. Working backwards, we estimated the time range at which Dylan Halley decided to pull the trigger. The total time from a simple visual stimulus to an action is about 300 milliseconds. A possible breakdown is the following. It would take roughly 50 milliseconds for a finger to pull the trigger. It would take about another 50 milliseconds for the command to travel from the brain to the muscles to pull the trigger. It would take 100 milliseconds to process the decision to shoot. Finally, it can take between 100 to 400 milliseconds to parse and understand visual information. When Halley started the process of shooting, Augustus is somewhere between this and this position, with his back turned to the police. It is impossible to ascertain whether Augustus is trying to pull the gun, as police claim, or steady it while turning. Professor Tiago Branco described Dylan Halley's process.
The question is, was the shooter reacting to any particular event that led him to press the trigger? That you might call a split-second decision if you want. Though I think the term is actually a bit misleading because it comes on the back of this escalation, essentially, which in this model of decision-making would be you're already pretty close to your threshold, and then you just need a little something else to take you over the threshold.
We analyzed the succession of actions and reactions that led to the shooting. At 5:30, 36 seconds, 19 frames, Megan Fleming, Dylan Halley, and Danny Tan had cornered Augustus. causing the situation to escalate and the threat levels to rise. At 5:30, 38 seconds, 3 frames, we see Dylan Halley's right hand without a gun. Augustus then broke Megan Fleming's grip on his shirt, causing his shirt to lift, exposing his gun. While Augustus was trying to escape Fleming's hold, we see Halley had pulled his gun and was pointing it towards Augustus. The gun was within Augustus's field of vision. Augustus had his back turned towards Dylan Halley while running in the opposite direction. At the same time, Halley cleared Fleming's hand from his line of fire and steadies his gun with both hands, preparing to shoot. Only then did Augustus's right hand move towards his gun holster. At 5:30, 40 seconds, Augustus's escape path was blocked by a patrol vehicle, causing him to brake and turn. This abrupt turn might have been the final trigger for Halley's decision to shoot. While stopping and turning, his hand touched his gun once more. 9 frames later, at 5:30, 40 seconds, 29 frames, with the police patrol vehicle clear of the line of fire, Halley fired the first shot. 7 frames later is the second shot. 6 frames after that, the third. 7 frames later, the fourth. 2 seconds and 4 frames after the first shot, Halley fired a fifth shot. The shot was taken when Augustus's body had already fallen to the ground. The recently released dashcam footage shows that, in fact, after the fourth shot, Halley took another 2 steps, reassessed, aimed, and fired for the last time.
It's possible maybe he made the call here that I'm going to shoot 4 times. What's weird is the fifth one. This is very, very similar, and this is maybe a little bit shorter, but they're very regular. It's basically determined by the kinetics of the actual finger movement, right? So I think that may make sense to think about this as one action, but this then as a separate action that required a second, more conscious decision, if you want.
We noticed that while Augustus's movements were reactive, Halley's were active, escalating. Justifications for the use of lethal force are evaluated on the basis of a reasonable assessment of risk from the perspective of the shooter and cannot be easily evaluated after the fact. In order to assess if Halley's decision to shoot was reasonable, we compared his actions to those of the other officers in the scene. When Halley raised his gun at Augustus, Quincy Jones was placing his gun back in his holster. At the same time, Leon Coleman was standing back, not touching his gun. Megan Fleming was also not touching her gun. Danny Tan was holding his gun throughout the incident. The moment Halley took the first shot, Leon Coleman and Megan Fleming are taking cover behind the parked police vehicle. Danny Tan has taken cover behind the black van, and Quincy Jones remains back. All 4 officers shared similar sensory perception of the incident. However, none of them engaged in the same way as Dylan Halley did.
That's the most interesting thing about this whole scene here, is that you have 5 policemen and only one of them shoots. And all of them have very, very, very similar sensory input, right? And the only thing that differs is experience. Their brains are seeing exactly the same information, but they result in different actions because they're interpreting their information differently or because their threshold for implementing certain actions is different.
The CPD's Force Options Directive instructs that in order to avoid taking split-second decisions, officers should create time by taking distance and try to de-escalate by engaging in verbal communication. If such advice was followed, Augustus could have still been alive.
Sensory evidence goes from the eye to whatever makes a decision and implements an action. If there's only 200 milliseconds to do this, there's only so many parts of the brain that can be involved. And most of the times, this process goes via what we call subcortical structures, which are more ancient structures in the brain, actually dealing with survival. So the regions in the brain that are very active when you're under threat bypass these more evolved areas and make very fast decisions. And that's a good thing in some situations. But that leads to a lot of biases and leads to errors.